exciting to be the one standing between you and your lunch. So, well, before we talk about the future, we should talk a little bit about the past, and I promise this won't be very long. But it started in around 1994. People remember Netscape 1.0 and the Mosaic before it? What's surprising about this is much of the Chrome, much of the buttons around the outside content window are, different icons, but the same buttons as they are today. You've got back, forward, reload, home, stop. You've got a throttle in the upper right letting you know if the page is loaded. What has changed over time, this is Netscape 2, again looks really similar except no icons here, is what you can do inside the content window. Netscape 2 introduced, among other things, frames, div, which is basically the workhorse of Web 2.0, animated GIFs, which we've come to know and love, and JavaScript. So before Netscape 2, you did not have in-browser ability to script your web pages. Just static content sitting there. If you wanted to do something, you had to do plugins, applets, use something else. And in this time, the state-of-the-art of web was a little something like this. This is Yahoo circa 1996. If you actually look at the HTML behind this page, it uses maybe 5 tags. So you've got your unordered list, you've got a head, of course the hyperlink, maybe a couple of paragraphs. I guess I lied, there's some fonts there. But there's no CSS, there's no JavaScript, there's nothing exciting. This is something a new student of HTML could bang out in an afternoon after looking at a tutorial. So that's what we saw. That was the state of the art 10 years ago. What's the state of the art today? Well, Firefox is, at this point, about 85 million users worldwide. It's about 2,000 community-contributed extensions. As of Friday, we're up to 41 languages, added additional 4. About 16% worldwide market share, and I'll talk a lot more about this. And thousands of people that contribute in some way or another to the code base, either in localizations, QA, marketing, or in the code itself. This was a present from the friends in Redmond, Washington on the launch of Firefox 2. It was quite a tasty cake. We made sure the interns tried it first. When we blogged about it, lots of people said, "Haven't you ever seen the movies? It's a trap. Don't eat the cake." But it was quite good. So let's talk a little bit about Firefox 2. Firefox 2 shipped in October of last year, and it included a number of features that are important to how you build inside the content window, features that are relevant to how you build content for the web. Among them is JavaScript 1.7, and I'm going to take you through that in a lot of detail as we go. It improved performance of the canvas tag. We'll also talk a little bit about canvas. We introduced WhatWG DOM storage, the first implementation that is one of the building blocks that's going to allow you to take your web applications off the web onto your laptop and use them on an airplane. Inline spell check. As more and more people use the web today as a primary way of composing documents and primary way of interacting, it's important to make sure that the browser doesn't make you look stupid by misspelling things as you type. And then as people use more and more websites, the tabs that are part of the Chrome in the top of the browser become a lot more like a workspace. Something that you'll have multiple of. If you lose it on a shutdown or a crash, is something that will ruin your day. And a lot more. But I'm not here to talk about individual features of Firefox 2. I want to talk a little bit about the web. Just to give you a sense of kind of uptake of Firefox, this is what the first 12 days of the Firefox 2 launch looked like. So that's about a little over 10 million downloads in 12 days. It's about 2 times, 3 times faster than the uptake we saw in Firefox 1.5. Just wondering what's different. Stuff changed. So it's just an astounding thing to watch as people swarm and download the browser. And that works out to, now I have to caveat, anytime anyone quotes browser metrics anywhere, take them all with a grain of salt. They're all imperfect measurements. This one just happens to have the prettiest pictures. So I'm going to show it to you. This is worldwide market share according to Zitimarketer, which is a French-based company. You can see, Europe is a very strong center in general for support. Asia is much weaker in general. US is still around 13–14%. If you break down Europe, you've got regions that are well north of 30%, some of them just breaking 40% in adoptions, others in the 16–20% range. Why is this important? It's important because it means that in many places, 1/6, 1/3, 1/4 of the web is using Firefox. It means as we introduce new features and add more support for advanced web standards, we're pushing the bar forward and hopefully forcing other people to come along with us and support the latest web standards out there to allow you to build your great web applications. How many people here are web developers of some form or the other? All right, good. Okay, so enough with the marketing and on to the technical. JavaScript 1.7. How many people have ever played with any of the JavaScript 1.7 features? All right. Okay. Doesn't count if you're in the Mozilla community. All right. So JavaScript 1.7 is a waypoint on our way to JavaScript 2. JavaScript 2 is going through the standardization process. It's also known as ECMAScript version 4. And they're looking to finish that work up by the middle part of this year. JavaScript 1.7 is something that's shipped in Firefox 2, so it's available today for you to use and play with. It includes a number of features, and I'll take you through them in great detail. I guess the other question is, how many Python programmers out here, or have at least a cursory understanding of Python? Okay, fewer than I thought. So a lot of the stuff you're going to see in JavaScript 1.7, a lot of the things that makes JavaScript 1.7 fun, is heavily borrowed from Python. So iterators, generators, let expressions, array comprehensions, destructuring assignment. I promise I'll go through these in a little bit more detail than bullet lists. So let's talk about them. So iterators. Again, if you've done Python programming, it should look very familiar to you. Construct an iterator from a list of objects of some form, and then you get to walk through that iterator using .next to get the values out until eventually you hit the end and you get an exception generated. Stop exception gets generated, then you can catch that exception and do what you want. Obviously, that's probably not normally how you would use an iterator. It's not the most useful code on the planet. What you'd more likely do is use them and the built-in try-catch that you get out of a for loop. So instead of initializing a variable, incrementing it, and checking the value in your classic for loop, you're doing what people are more used to these days, which is basically saying, for foo and foods, do something useful with that variable within that for loop. Generators are a little more interesting. They allow you to yield control from within one of your statement blocks and return a value back. So in this for loop, I'm yielding control back and passing the value of I in my for loop. That generator will then return an iterator, which I can use together to do things like this, where I can use my function to generate new values on the fly, and again, use stop iteration. So these are nothing new, nothing you couldn't do in some form or the other in an early version of JavaScript, but certainly make it a whole lot more fun. A lot less code, a lot less redundant issues. Blocks. So block is a different way to scope your variables. It's like a better bar. You can declare let variables within different scopes, and function scopes in particular, so that value of that variable is locally scoped in there, does not collide with any global scope. Let variables have basic default scope within for loops. So again, you can combine these structures together. You can use iterators. You can use let values to have effectively local variables within a for loop. So again, for your Python programmers, array comprehensions, easy way to initialize an array. Why write a for loop to shove a bunch of values into an array when I can just do it in line here? So what we're doing here in this case, we're generating an array of squares. So we're saying I times I for I is a count of 10. Again, using iterators there in order to create the first 10 squares. And then we can print them out. We can do odd squares. We can do creative things like creating a packed matrix where the diagonal has been removed. Again, not something you probably do on every Web Citadel assignment, but looks neat on a slide. All right, probably one of my favorite things, destructuring assignment. Again, why have swapping the A and B variables instead of loading it into a temp? You can just basically do it in line. Even more useful than that is being able to return multiple variables from a function. So you can, in this case, assign SV and O to the output of whatever function this is that returns it. Works for objects as well. Works within for loops. So again, this is where you can write code to say things, to do slices and for loops and iterators together. So I can say for foo comma bar in foo bars, then use foo and bar within the body of my for loops. Again, nothing you couldn't program in a different way before this. It just makes it a whole lot more fun, a lot less code, much more compact. You can also do some crazy things. So Neil Nix said, what if we took the yield statement and tried to build basically threads within JavaScript? You know, as you know right now, the JavaScript runtime is built in the browsers as a single thread. So what you can do is use a technique called trampolining, which is basically like cooperative multitasking. You can basically pass control back to your parent thread and build effectively a thread library. Now, what's interesting about this is not that you actually want to do this in real life. What's interesting about it is by building on the basic features of generators within JavaScript, you can generate something like this in this case, 4K of code versus the 90K of code it used to take before to do this. So that's JS 1.7. And I'm going to talk a little bit about JavaScript 2 towards the end. I think the other exciting thing, again, these are all things you can do today, is Canvas. Unfortunately, we had some AV issues, so I can't show you the demos. How many people have seen the Walker demo in Canvas? Okay. For those of you who can't, it looks just like this, and it looks like Doom, you know, circa 1994 maybe. But Wolfenstein 3 is probably closer, Pathways to Darkness for you Mac fans, old Bungie game. You know, it lets you run around a maze, it's textured, it's all running straight within the browser. You're not downloading a Java applet or anything like that. And it's using the Canvas tag. Canvas tag is a tag started by Apple and then picked up by us in Opera and put into the WhatWG working group in order to standardize. Allows you to draw images within a div or other element within your HTML page. So if you've ever done 2D programming of any kind, move to, line to, fills, copy images, all the basics are there. You can build really powerful things. It's not just for toy demos. If you've seen Yahoo Pipes, so this launched 2 or 3 weeks ago. It's a way to kind of live mix up data from the web. So I can grab one URL, grab from another, you know, put them together, summarize, and generate, for example, a new RSS feed. We've got this really killer editor which lets you drag around the boxes to adjust where the input of one workflow effectively goes into the output of another. And this is all done on top of Canvas. So again, fire up my browser, point it up there. I can drag the elements around. I don't have to load any plugins. Allows you to build what you'd expect on the desktop, which is a really rich web application. So that's what you can do today with today's technologies. So what are we going next? I'm going to talk about 4 different things in terms of where we're going next. First, in terms of JavaScript itself, talk a little bit about JS2, JavaScript 2. We'll talk about the basic building blocks required to take web applications offline. So this means what you can do to take your web application, disconnect from the net, and still use it. Talk a little bit about microformats, and talk for about a second about what we're doing with web tooling. So, JavaScript 2. I think there's 2 very common answer questions that Brendan and other folks who are deeply involved in JavaScript 2 get asked. The first one is, why the heck are you touching the JavaScript language? All the browsers can't seem to agree today on how to implement it. Why are we creating this whole new standard and this major rev of the language? And I think if you look, as I take you through kind of some of the goals of JavaScript 2, it really is about taking the web forward and taking us out of the blink tag and unordered list from the early 90s and into these entire office suites of web applications on the web. And so what we're trying to do is, number 1, fix the problems that people have been griping about for 10, 12 years using JavaScript. And number 2, really support programming in the large. This means lots of people collaborating together to build web applications, and doing so without a whole lot of shenanigans along the way. So I'll take you through a tour of some of the big parts of JavaScript 2. First is typing. So JavaScript as it is now is mostly untyped language. What we're adding in JavaScript 2 is the ability to do type annotations, and I'll talk about this in a little bit, in order to get better invariance at runtime, to make sure that you can program with contracts, to make sure you can write functions that expect certain values and it's checked by the system rather than checked by you. In order to allow you to build applications that are big and suitable for the web, adding namespaces and packages, and some of the features that I talked about in JavaScript 1.7 are already implemented in terms of destructuring assignment, iterators, generators. I didn't talk about operator functions as part of JS2, and some improvements to the basic objects. So I said the first question was, why the heck are you doing JS2 in the first place? The second question is, oh my God, JS2 looks really big. Did you take on too much work? Why are you doing this big language rev? And I think a couple of things happen. If you tease apart everything I'm about to talk about here, it really boils down to two or three major things. The first is the introduction of types into the JavaScript language and building a sound and formal type system. And that's not something you want to do kind of piece by piece, something you have to do basically in one whole shot. The second is really to just fix up some of these problems that have plagued JavaScript for a long time. And the third is to add a lot of the syntactic sugar, a lot of the niceties around iterators generators, let you build these web applications. So let me take you quickly through some of the basics of types. So types, first of all, again, it's type annotation, which means it's optional typing. You can still program the same way you did in JavaScript 1, just not using types to your variables. But if you choose to, you can declare variables with types. You can write function signatures that request certain types on them. So in this case, we're saying writing a function which takes an int, a string, and a generic object. You can do multiple parameterized values passed into a function, so you're not fixed to a single prototype. You can have basically a set of fixed variables plus whatever else, and people can pass in different amounts of arguments and send that as an array. If you use Java generics, or if you've used templates in C++, you can build parametric lists and parametric types in JavaScript as well. So you're able to construct a list of only type T or type foo, whatever it may be. You can also use structural types. So if you don't want to build classes, you just want to build structs, groups of objects together that are used in them. I think more interesting and exciting is the use of classes. So this is again going to look very familiar if you've done work in Java, if you've done work in Python, any of these other languages. You're going to see ways to encapsulate both data and functionality into structured objects called classes. Classes look a lot like classes do in Java, frankly. You can derive a class from another class. By default, it's sealed against mutation. It looks a little bit something like this. I extend another class. I have a set of function declarations and implementations there, and I can construct it just like I would do in any other language. Interfaces. Interfaces are like classes, except there's no implementation. The key difference, very similar to Java again, is that any class can only extend one other class, but can implement multiple interfaces. So with an interface, you're trying to define a contract and not defining any implementation of how this actually works. And so again, you'd see something, looks a little something like this. I declare an interface, which is simply a set of effectively method signatures. I then have a class, or multiple classes in many cases, which would implement that interface. You can use structural types as well. So you can declare types as just either a function or a series of data members with no implementation. So that's the basics of classes. I went over that really quickly, but if you've used any of the other modern programming languages that use object orientation, allow you to encapsulate your functionality and your data into one object, that's effectively what we're doing here. Again, making it familiar for people, making it fun, making it easy to build large systems within JavaScript that run on the web without any installation of additional software. The other key part of this is namespaces. So if you build classes, you're going to want to make sure that you can have certain parts of those classes that are exposed to other classes and certain parts that are private parts of the implementation. So in this case, we can declare public, private, and internal implementations, and this is on a per class basis. So, and the namespaces are used fairly generically. They can use both the namespace entire package systems. So in this case, I'm saying in class C, function is in the improved namespace, and I can basically call the namespace directly by qualifying it while I'm calling it, or I can import an entire namespace, and then I can use it shorthand without having to fully qualify the namespace as I'm going. This can be used to build packages. So if I want to create, for example, my org Venkman package and implement a series of things in there, then I have different ways, just like you can import packages in other languages, to import an entire package or selectively import individual classes. Again, this is super important, mostly for when you're building huge systems. I'm going to take data from different parts of the web, different people implementing it, and you don't want to pollute the global namespace. You don't want to have flashes of classes and variables. It allows you to encapsulate what you're doing and make sure that you're safe from other implementation. Decimals, and they only bring this up because this is one of the most duplicated bugs in Mozilla, which is why the heck is 7.49 minus 35.99 equal to that number. So there's a new decimal type that will be implemented. There's a long number of other small features in JavaScript that I'm not going to go over now that improve a lot of these sorts of issues. Issues that people have to bang their heads on over and over again and fix and work around in the browser. And this is coming real soon now. As I said, the spec is being worked on now, will be done around the second quarter of this year. And what's also different about this version of JavaScript is there's a reference implementation being developed in parallel in ML. So it means it's not just a wiki or Word doc. We'll actually have a working, running reference implementation that all the browser vendors can compare their implementations against to make sure we're getting a better shot at equal behavior across all the different platforms. The other exciting announcement that you may have seen is that Adobe has decided to donate just-in-time compiler for ActionScript/JavaScript that we're now calling the Tamarind project. So they announced this in the fall. And that will be integrated into a future version of Firefox. So it's going to allow us extremely high-performance JavaScript on the web. Just-in-time compilers, obviously, a way to get virtual machines to perform extremely well. The other thing to note is that this is probably the last big bang rev we're going to do of JS in a long time. Realize that it's not like all browsers are going to adopt this overnight. It's not like all websites are going to do it. It's going to be a slow adoption. But once we get there, we're going to have technology sitting on your desktop on 90–95% of people's desktop that will allow you to build these big, rich applications without installing any additional software. So that's JS. JS2. Yes. Yes. Don't read that word, it's spelled wrong. Thank you, Axel. All right.
How does this JS2 proposal relate to previous JS2 proposals that may have been done 5 years ago?
Kind of doesn't.
It doesn't at all.
Yeah, it's kind of a restart. So, all right.
Just where are the other browser implementations in terms of supporting JS2?
Yeah, it's a good question. There are other browser vendors participating. ECMAScript is an open standards group, so there are many other people participating in the standards. Firefox is probably furthest ahead. JavaScript 1.7 is kind of a halfway point to JS2. No one else currently has 1.7 implemented. We probably won't have JS2 implemented until sometime 2008. And we'll probably be the first since we're heavily involved in there. So you would expect, this is something that's coming over the next couple of years. Not something you're going to see this year in most major browsers. Obviously, I can't speak for anyone. I'd hope they implement, but I never know. All right, enough JavaScript. Let's talk about offline web apps. So, does everyone get the basic concept of what we mean when we say offline web apps? So, it means I'm reading Gmail, looking through my mail, either have, disconnect my laptop, go on an airplane, Wi-Fi's bad, no reason why I shouldn't be able to read all of the messages I've already downloaded. Just like any desktop application that allows you to look at what's on your desktop without having to connect to the internet. So what we're doing is building the basic building blocks that any web application can use to take themselves offline. So offline really composes of 3 main parts. First thing I've got to do is I've got to be able to access and store data offline. So if I'm building an offline email client, I have to be able to take my messages, my email messages and headers, and shuffle them somewhere on the disk and be able to access them when I'm not connected to the net. And so that's implemented via WhatWG, which is the What Working Group's informal standards body, DOM storage. And that's already partially implemented in Firefox 2. The second thing I need to do, so if I can store my data offline, I need to be able to store code and other resources. So I've got JavaScript, which is going to run in the browser on my offline application. I've got CSS files, I've got images, I've got other things. I need to make sure I can get to that stuff without having to download it over the net because I don't have a net connection. And so that's where we've had offline cache, which I'll talk a little bit about. And then the last thing, obviously, is your app needs to know whether it's online or offline so that it can behave properly. It can resync when it comes back online. It can make sure to not make network requests when it's offline. And so we've added online and offline events. So let me take you through each of these. DOM session storage. DOM session storage, you can think of it basically as a big hash table on the local disk that is associated with your session. So it goes away if the browser is explicitly closed. It stays around if it crashes or something else happens. And you can use it to basically fetch any string value you want. So in this case, I'm just shuffling the value of the checkbox on my web page into my DOM session storage under a variable named insurance. And then I can go back and I can query the value of that variable later on within my session. Even more interesting probably is global storage. So it's the same thing. It's a hash table that I can use to store values, except that it's a per domain value, and it's persistent. So I can store a value, shut down my browser, restart my computer, start my browser back up, pull the value back out without ever having to go back to the net. And so this is one of the basic building blocks of building these web-based applications. Security is obviously an important issue. We want sites to be able to securely store the data there. So domains can access subdomains and vice versa. So you can build a series of tiered sites that can share data across them if they want. But we don't allow cross-domain sharing. So obviously www2 example can't hit www example site. All of this is specified in the What's WG working group's specifications. Much of it is implemented in Firefox 2. Again, we hope other browsers will continue to implement, and we'll finish the implementation in Firefox 3. The last part of this whole puzzle is the offline cache. And that's as complicated as it gets. It's a linked rel. I basically tag my resource, and I'm saying, JSON.js and to-do.html. I want you to pin them in the cache so that when I go offline, I can make sure I can access those resources. And make sure that my HTML is there, my CSS, my JavaScript, whatever it may be. By simply adding these additional metadata onto your web page, we will make sure to pin it into the cache and make sure it's available for you to use offline. And this works in the latest nightly builds of Firefox. Yeah.
What happens when I don't have enough space on my device?
We don't know yet. It will probably go away.
What happens if every website on the planet says, hey, I'd like my website to load faster next time you come back. I'm going to put all of my useful resources into the offline cache, even though I'm not doing an application.
You'll fill up your cache, and we don't know what will happen. Yeah, it's bad. That'll be bad. Don't visit those sites. This is the future, so we don't know it all yet. If I knew it, I'd be playing the stock market and not here talking to you. So, not too good, but there's lots of things to work out. This is, happening in real time in terms of doing it. We just started getting this going. Last thing is online, offline events. This is really simple. It's basically how does your code, how does your application know whether it's on the net or not? And it starts with a Navigator Online property, which I think actually already existed, which allows you to just query in real time, hey, am I online? If so, I should probably shuffle my data up to the server. If I'm not online, maybe I should shuffle it to the local storage and deal with it there. And equally as important, rather than checking in a loop what's going on, there's a new series of events going online and going offline, or offline and online really is what they are, that you can register event handlers for to be notified when your app goes offline. So in other words, if I want to wait, get notified when I go online and automatically sync my data back up to the server, I can do that quite easily by registering an event handler, just like you would do anywhere else. And keynote crash. Oh, there we go. Little preview of the future there. All right. So as I said, unfortunately, I can't show you the demo, but because I have it on the other machine here. But it turns out to be, with these three building blocks, relatively trivial to build applications. We've got a couple of sample applications. One is just a to-do list that allows me to store a bunch of data locally. And the other is, if you've heard of a company, an open source project called Zimbra, it's a mail calendaring, basically, server that has an open source edition. It's kind of like a Microsoft Exchange competitor, but all open source. Someone from the Mozilla project spent about 5-6 days, took the source code, and made it fully offline compatible. So you can compose emails offline, drag them around folders. When you get back onto the server, it can go into the sandbox and send them out. So this is not something that requires people to completely re-architect their web applications, to download new stuff, to program in a different language. It's literally just take your application, make sure your resources are organized in ways that we can pin to the cache, make sure you know when you're online and offline, and store data offline. So as this gets implemented, we're going to see probably a lot more applications do this very, very quickly. And there's all sorts of easy use cases. Read email, RSS feeds, even Google Docs and spreadsheets, being able to take a doc offline, read it on the plane without having to explicitly download it beforehand. So that's offline. Second part of the future of the web. The third part, microformats. So, people here know what a microformat is? Okay. No one's going to say no, right? The microformat, basic idea is pretty simple. It's just, there's a lot of unstructured data on the web. I go to any web page, I'm looking to order a pizza or go out to dinner. I'm going to see a phone number, I'm going to see an address, I'm going to see an email address, right? I'm going to want to do useful things with that. I'm going to want to call the phone number. I may want to shuffle the address away in my address book so I can do something useful a little later. I may want to add an event that's got a date on it to my calendar because it's something I'm going to go to. And today what you do is you use, they used to call it kind of green screen cut and paste, where I kind of cut and paste, grab the text, drop it somewhere else, maybe reformat it, and hope that it works. So the basics of microformats are, hey, if we encode a little bit more data in there to let you know that this is an address, or this is a date and time, or this is a phone number, you can start to build clients that do intelligent things with that information. So we've already built, Michael Capley built an extension called Operator, which is available to download now from Firefox. And what it basically does is it looks for content on your web page and tries to do useful things with it. So in this case, if you go to Yahoo Local, you look for an address for pizza delivery or a restaurant. Instead of, again, manually cutting and pasting that, you'll see in the upper left that it's found this information, and you can take this contact and export it directly into your contact store of your choice, your H card, B card system of choice. And so if you're on a Mac, it'll take it and jam it into the address book, and now you've got the address and phone number that you can call on and do something useful. And so the basics of microformats that we're looking at to try and do in future versions of Firefox, and hopefully on the web, is to build the basic building blocks so that it makes it really easy for web authors, for extension authors, and other people to expand the set of microformats. It's not going to be a set of things that we ship in the browser, but rather ways to discover that you've got content on the page, a unified way to notify people that, hey, there's something on this page you can do, you can act with. This is a toolbar as a prototype implementation. It's certainly not done. You can imagine hovering over the address with a little sticky pop-up or whatever it may be. Or we're going to build the basic building blocks to make it trivial for someone to say, here's a new content type, here's a quick parser for it, here's what you do with the data, and plug that into the browser. So that's what we're doing with microformats. And the last thing is another demo, unfortunately. Some other time I'll show you. It's pretty sweet. The last thing, everyone here who's done development on the web has probably seen Firebug. Firebug is pretty awesome. Firebug is an extension for Firefox. It's basically everything you've always wanted in a JavaScript/CSS/HTML debugger and more. And I think what's important about this is when you think about what we're trying to do with the future of the web, we're trying to make it possible and we're trying to make it fun. Because for a lot of us, programming isn't just like a job, something we do. It's something that's fun and interesting to us. And so aesthetics matter. Banging my head against the wall is a problem that I know there's a better way to deal isn't something I'm going to keep doing after a while. And Firebug is one of these things that makes development fun. You can twiddle with CSS. You can get timings to figure out exactly which part of your script is running slow. You can watch HTTP requests go by and figure out which things are hitting the server when and where. And so this is the beginning of trying to bring tooling on the web up to par with what you've seen in other applications, to make sure that it's not just a text editor and the JavaScript console are the only weapons you have of choice when you're building web applications, but making sure you have a totally rich tool set to build these things. So again, what does all of this stuff mean? So you heard me ramble on about typing and about iterators and generators, all this gobbledygook in JS. But at the end of the day, what we're trying to do is make it so big teams of people, collaborators from all over the world, can get together and build the next generation of web applications. Things that we couldn't even think of today on the web. We want to make it fun. We want to make it aesthetically pleasing. We want you to sit down, develop something on the web and say, oh, that's cool. Look, I can just do this kind of thing, this iterator thing, instead of writing all of this code. Because then you'll do more of it. That's what really motivates people. We're trying to make the web indistinguishable from the desktop. What I mean by that is there isn't anything you should be able to do on a desktop application that you shouldn't also be able to do on a web application. If you think about what the few things are that case right now, we're going to take care of them this year. So the first thing is offline. Again, I can't sync my data offline. We're going to fix that. We're going to do it in a standard compliant way so other people can come along and make it so that you can take your web applications with you on the road. Graphics is another big area. You're seeing a lot of eye candy in desktop applications, and the web is slowly catching up there, but you're starting to see things like better SVG implementations in all the browsers, and the canvas tag that allow you to, again, do these rich graphics that aren't just toys, that allow you to build graph editors in other projects. So you're going to see those kind of things getting done. And then the last pillar is performance. So by increasing the performance of the JavaScript engine and the scalability of the JavaScript engine through a just-in-time compiler in the future, you're going to be able to build even bigger web applications than you can today. And again, much of this is here now. Much of this you can play with, either in existing versions of Firefox or future versions. Much of it is specified either in the ECMA working group or the WhatWG documents, so that everyone can test their implementations and make sure it works. So that's the future of the web. And I know it because aliens told me about it. Questions? Stun you into silence. Yeah.
If I serve an application with your SSL, it doesn't cache anything.
Right.
That's going to be like put in the even over SSL, it's fine. It's going to work with offline caching. What about security updates?
Yeah, I don't know the answer to that. It's a short answer. So probably will not. The caching system doesn't store anything persistently now. Whenever as you know, we never cache the disk in SSL transactions. We do cache for RAM in certain cases. Likely those two things won't be compatible. You may have to serve up some of the content over HTTP. I don't know if we've gone that far yet.
Looking at some of the JS2 stuff, will it change the way extension developers interact with XPCOM or
Is there something about XPCOM that's more specific in there?
It's a little bit laborious as far as code registry, lookup, things like that. And it's all the interface stuff, and it kind of smells a little bit like some of the main XPCOM as far as exposing some browser functionality. Instead of exposing it in JavaScript language instead of XPCOM.
Yeah, so it's probably not. So the question was, for Firefox extension developers, will JS2 help me not have to deal with XPCOM? And the short answer is JS2 probably won't. But over time, because we're making JavaScript an easier language to build components of the browser, because the performance of the engine is increasing, basically almost any code we touch in the browser these days, we're writing in JavaScript, unless there's a really good reason not to. So the main rendering path will probably never be in JavaScript, but an easy example is the password manager, right? There's nothing really performance intensive about the password manager. It's a whole lot easier to write and work with in JS. And so you're going to see this as we evolve and touch different parts of the system, a lot of stuff implemented in JS and exposed through JS interfaces, hopefully, rather than going directly from Lightning. But
A comment on that, the fuel thing should probably help quite a bit better.
that's the other thing we're doing, is trying to build better interfaces across things. I don't know if you've seen Fuel. So if you go to developer.mozilla.org, it's on there. Fuel is kind of the first start of what are all the common things extensions do, and how can we put that into a nice little library that everyone can do to, do common operations within Firefox.
Accessing preference that it's good confidence and that kind of thing there. That's what I'm doing that make that really easy. They're like nice little templates in JS1 setup. Where you can basically get rid of all the usual XPCOM terms and just make it from that and then automatically does the UI that you use. So that's samples out there.
is that going to be official or is it going to be like JS?
I'm sorry. For no. I'm sorry. The question was, will we have an IDL compiler for JavaScript? So, and we're confused as to what the answer is. Or it's not very helpful. Sure.
Mike, you talked about taking all desktop applications to the web. When are we going to see web-based video editing?
It's already there. There are some applications out there that allow you to do some basic web. The question was about web video editing. So it's probably not as good as Final Cut, but we'll see. I think it's going to stress Canvas a little bit, so I think we're there. But we'll get there. Yeah, the back.
How about security and Because how do you not make sure that users notify that sites are using offline cache and, for example, when using public computers?
Yeah, that's a really good. So the question was offline caching and security. How do you notify users if they're doing that, and especially if they're, for example, on a public shared web terminal? You're not going to like my answer, which is another one of these. We're still kind of figuring it out. There's a couple of parts of security with offline caches. One is let them know that the data is there. Two is, in Firefox 2, it's all plugged into the clear private data function. So there's a feature in Firefox to basically remove all my cookies and history and anything that might be sensitive and personally identifiable. So the offline cache is already plugged into that. So that will also get cleared if you clear private data. So that's the easiest one, which is just, if you're ever using a computer that you don't want people to see what you're doing on it, just clear your data and you're gone. In terms of letting people manage the storage and see what's there, which sites are using it, that we haven't actually gone down far enough the path to understand what the UI is going to look like there yet. You've already got one, so I'm going to give it to someone else. Yeah. You want to answer the question? So the question was video and codecs and what's your future of that? It's something we're really interested in. I don't think we're going to get rid of lots of different codecs in the future, but there has been a lot of questions about. What's that? Yeah, so there's a question of should we embed video and audio codecs into the browser? And I'm pretty sure video already is a big part of the web as is audio. Whether it belongs in the browser with some kind of pluggable codec system, so that at least the basic frame of the player is there, or whether it continues to belong in plugins the way it is today with Flash and QuickTime and WMP, I don't really know yet. I think that the one thing we are really interested in is and push it down what kind of pipe? Possibly. I think the thing that's most interesting to me about video is how to make video jump outside the little box and actually interface with the rest of the web. And so if performance weren't the issue and you could have video within a canvas tag, for example, be able to style, rotate, have it interact with other pieces of the content, I think that's where the future of the web is with video. How that's actually implemented, we're still kind of figuring it out. Question in the back?
Is there any way to do something like a security manager in Java? In Java, just stick a declaration at the top of the page and then let the browser handle, instead of having to actually filter the JavaScript and doing what you don't want to do. It's still part of JavaScript.
Yeah, I'm sorry, the question was, can you implement a security manager in JavaScript? What is to do permissions, or what is the thing you're trying to do?
I want to prevent it from making links to external websites and things like that.
Yeah, it's the answer is yeah. We would like some ways to declaratively. It's been a common problem on the web these days for people who have to do content filtering. So if you have user-generated content, you upload it to a page. You have a small bug in your content filter and someone's able to get some code through there, and then whammo, you've got a cross-site scripting attack on that site because I can upload code and run it in the context of your session and steal your cookies and then steal your blog and do whatever I can do with that. So we are looking heavily at ways to add some declarative parts to JavaScript. Some really basic ones would be basically like no JS after this, within this block, or no JS after this tag's loaded, so you can scan things out. Lots of different ways to try and do it so that you as a website author don't have to deal with it, especially as the specs for things evolve. You don't have to keep up with what all the latest tags are and that sort of thing. So it's another one of those, yeah, it's something we will be doing soon, hopefully.
There's a proposal for that at jerv.net/security/content-restrictions, which I'm hoping to get to in the next couple of months.
Cool. Probably one more question, and then we're Time to eat? No? All right, thanks a lot. Appreciate it.